Okay, welcome back. So we'll continue. Uh, just kind of reminder for people, as we had some technical issues, we are running a bit late here. Hence, what you need to do is actually turn off the auto follow on your swap card. It's on the left top corner. So please do that, because otherwise you are going to actually jump into the next session. And as said, as we are late, so you want to turn that one off. So with further ado, let's get into the agenda. What we actually have next is a couple of 5G talks. The first one is actually Dean talking about the 5G unicorns, separating myth and reality. So with that said, Dean, over to you.
Thank you, Mikhail. So, hi, and I've got a 15-minute slot to tell you everything you need to know about 5G and try to really boil that down. I'm an industry analyst and advisor. My Twitter handle is Disruptive Dean, which should give you an idea of the fact that I perhaps take a slightly contrarian view on various aspects of technology. And I'm a specialist on wireless technologies, some of the policy issues around telecoms and communications, and some other stuff around voice and unified comms and sort of more general futurism. But today I'm going to talk about 5G. And what this is not is one of the typical 5G presentations you may have heard before. So I'm not going to be talking about the infamous triangle of use cases. I'm not going to talk about self-driving cars. I'm definitely not going to talk about robotic surgery or remote surgery. You won't hear me reference the so-called race to 5G, which is mythical, and neither will I be talking about trillions of dollars of GDP. General rule, I believe, is the more zeros you hear in a forecast, the least credible it is. So what I am going to talk about is where we are with 5G, what it can do, and more importantly, when it will do that. To do this, first, I want to set the scene. And so first off, I apologize for the simplicity of this slide. I could only get 6 dimensions rather than the full 15. And the point here is that wireless is complicated, and there's lots of different technologies, there's lots of different use cases, lots of ways of dividing up spectrum, lots of business models, lots of issues around where you have networks indoors, good full coverage, partial coverage, and so on, and different speeds, different latencies, different ranges. The net result of this is there's never going to be one technology to rule them all in wireless. We are going to have a heterogeneous mix of wired, wireless, internet-based, non-internet-based, low latency, high reliability, low reliability technologies into the future. And that's got a whole bunch of implications for how networks get deployed, and then also indirectly when you're connecting from a wireless device to the cloud or to the public internet, what that means in terms of a peering and interconnect model as well. And I think the thing to point out here is that there's going to be this diversity in slightly unpredictable fashion. And we will see a lot more 5G rather than 4G for normal mobile use. But for things like IoT, it's going to be very use case and application specific. You're going to see a variety of different actors, as well as the normal big telecom service providers that are rolling out wireless networks. And that's a really critical part of all of this. So where are we? The first thing is 5G will come in multiple phases, and this roughly aligns with the generations of standards from 3GPP. But to be honest, it's more philosophically looking at this in terms of timelines. And at the moment, we're in the middle of what I would call 5G phase 1. And 5G phase 1, to be honest, is 4G++. It's faster, it's a bit lower latency. If you have coverage, it's high performance, but it's not everywhere. And there's essentially 2 main use cases for it. Is mobile broadband, which is what we all use on our phones and perhaps a few laptops, and then there's fixed wireless access, which is going to be more important as well. Over the next 3 to 4 years, you'll start to see later versions of 5G come in, which start to bring in some of the cooler, newer features you'll often hear about, lower latency to begin with, and at some point, very low latency. Debatable on the ultra low, but we can come on to that perhaps in the Q&A. You'll also start seeing things such as what are called network slicing, which allows virtualization of 5G networks for different purposes, although you can ignore most of the hype about individual companies buying slices. Initially, it's going to be very coarse-grained virtual functions on top of the one 5G network. Over time, it should progress. And at the same time as you have all of these sort of progressive series of advanced features in 5G coming on, you also have new companies deploying 5G. And you'll in particular get enterprises, managed service providers deploying localized 5G networks for industrial sites, perhaps for cities, perhaps fixed wireless access in rural areas. There's a lot of interesting new things that come in, partly because of changes in spectrum rules in some countries around Europe, but also because a lot of the necessary elements of 5G, like the cloud-based core network, will be a deliverable from the cloud, which perhaps will, in the medium term, reduce entry barriers for new providers. One thing to point out is 5G is currently, in most places, very, very patchy. It's worth saying that the moment you can't reliably create a 5G specific application because you don't know as an application developer when and where the users will be on 5G versus 4G, and even within 5G there's very different capabilities depending on what radio you're connected to and what spectrum bands you're connected to. And at the moment, this will change, but at the moment you have reasonably still quite high latency on most commercial 5G. 20, 30, 40 milliseconds is not unusual. So ironically, at the moment, you probably get better latency on Wi-Fi if you're indoors, perhaps better speeds download on 5G, but actually upload is very variable. And actually, in some cases, uplink speeds will be better on 4G or Wi-Fi than 5G. Now, over time, you'll have more 5G, more reliably in more places, but we're not there yet. What I would say is that 5G is going to make a big difference for certain applications in certain locations. So forget about the augmented reality in your living room, that will still be on Wi-Fi. Where you will make a difference is 5G in industrial and enterprise settings, where you can precisely engineer the network coverage and performance to the needs of whether it's a factory or a warehouse or an airport or something like that. And I think those localized capabilities will be very, very critical. Remote control of vehicles is one where the low latency over time, lower latency will become very important. Perhaps not on public roads for quite a long time, but things like construction sites or maybe snow plows, where you perhaps got less of an issue around insurance and liability. That might be a promising source of revenue for service providers, either established telcos or new providers. Fixed wireless access is going to be important in 5G, as well as 4G, to be honest. It's not going to replace fiber, but older DSL services in some places perhaps will be better off on wireless. It's going to depend on the specific location, what the backhaul looks like, and also critically from the point of view of the IXP sector, whether you could do local breakout near to the home so you can get a straight link to the internet and the cloud. And there's also going to be over time some use cases in things like public safety. So you can imagine a video link to a moving ambulance to assess a patient before they get to a hospital. Something like that can make a big difference. Perhaps one way of looking about this is, rather than thinking specifically about 5G, think about a cluster of technologies and what we can think of as being the 5G era, which is emerging. And there's a bunch of things in terms of new forms of Wi-Fi, like Wi-Fi 6 and 6E and eventually 7, which are going to apply for indoor use. You're going to find later versions of 4G with essentially gigabit performance as well, fiber, various enablers around core networks and cloud delivered capabilities in the networks, perhaps edge computing. And edge is a whole different area which I could talk about in this context, but you have to separate. The key thing on edge is separate out, if you like, the customer facing edge, so perhaps AWS wavelength or something which is designed for customer applications, versus the internal use of edge compute within the network itself to run part of the radio infrastructure or the distributed core network of a mobile operator. So I'm having to go through this pretty quickly because I know the event's a bit behind time and I've only had a 15-minute slot. So hopefully we'll have time for Q&A. Where are we in Europe with 5G? Well, these slides are from the EU's 5G Observatory site, a couple of months out of date. Since this is launched, was published, there's been launches in Bulgaria, in Croatia, and another few around Europe as well. What we can expect is by the end of the year, there will probably be between 10 and 20 million subscribers on 5G in Europe, catalyzed in particular by the arrival of the new iPhone. And so it's a moderate. It's to give some comparison. There's 10 million in South Korea alone, and there's probably going to be 100 million plus in China. I'm not sure what the number is for the US. So European development of 5G is starting slowly, but will accelerate quite a lot more through next year in 2022. And one of the key ingredients is around the availability of spectrum to build out 5G networks. And we're starting to see not all countries release the primary bands for 5G. And the one you'll hear talked about, if you're a wireless person, is the 3.6 to 3.8 or 3.4 to 3.8 gigahertz band. And France, I think, has just concluded that, but there's a couple of other countries where they're still delayed in launching that. So I'm just going to skip on now, and we'll come. Actually, one last point on the spectrum before I do that is you'll hear people talk about millimeter wave. At the moment, millimeter wave 5G it offers the highest performance, but also the shortest range, and doesn't go through walls. It's not yet a thing in Europe. There's only a couple of countries licensed it. It's more important in the US at the moment, but I'm a bit of a millimeter wave skeptic, although over time it will become more important here as well. And that's what you really need to do some of the really low latencies. What changes, what doesn't? Well, one of the key things is that the 5G networks are built differently to previous generations of mobile networks. At least in theory, you will find more chance for local breakout to local peering points in 5G, but that hasn't happened yet. What we are starting to find is that some of the operators are blending their fixed and mobile networks with the same core. It would be interesting to see whether they have separate links to the internet from each of their regional data centers. But at the moment, that's not happening as fast as we might have hoped. One of the things that we will certainly see is new forms of network owners. I'll talk about that in a minute, private networks in particular, as well as fixed wireless access, a whole range of new application and service types. Some of the stuff is around IoT, and particularly sort of critical and industrial IoT. There's a lot of hype about things like AR and VR, but to be honest, most of that will get used indoors. And indoors, you will still primarily be using Wi-Fi, certainly in a residential setting, and often in offices as well. And I think, particularly given the pandemic and work from home, there's at least as much of a leap forward with Wi-Fi 6 and 6E from previous generations of Wi-Fi as there have been with 5G from 4G on cellular for the wide area. One thing I will say is there's new business models emerging here. So you'll see people talking not just about the normal subscription models, but there'll be both private and wholesale variations of 5G. There's a particular term called neutral host, which is very interesting, which essentially is an evolution of the network sharing model we've seen in previous generations of mobile. Also, governments are focusing on 5G. To my mind, sometimes they get it wrong. They seem to have bought into the rhetoric and the hype and the unicorns, if you like. And so they're certainly concerned about it. And you see that's impacting the choice of vendors, but also it's sort of causing a sort of bit of a self-perpetuating issue where people have told governments that 5G will be running everything, and they now believe it. And all of a sudden, they've sort of thought, well, if this is going to be running critical infrastructure, then we need to take more of a close look at it, which has its upsides and its downsides. Upsides are around investment in perhaps test beds, trials, incentives. Downsides, it tends to add in bureaucracy at some levels as well. Certain things will be unchanged with 5G compared to 4G. Indoor coverage is going to be poor for the most part, particularly for the higher performance. Similar sort of devices, no, we won't all have 5G laptops. Well, there'll be a few of those around, but not that many. And a lot of the other stuff, it doesn't replace Wi-Fi, it doesn't replace fiber for the most part. It's a complement to those, and you'll find a sort of narrow overlap on some of the Venn diagrams. But I would say that some of the hyperbole is overdone. One thing that people will talk about is the transformation of industries due to 5G. And in some cases it's true, although it's not as much of a transformer as, say, AI or the cloud. But ironically, the industry that's going to get most transformed by 5G is the telecoms industry itself, partly because of the new architecture and partly because of the interest in industries and other stakeholder groups to play an active role. It's no longer just a telecoms technology, it is more of an infrastructure choice along with other aspects of IT. And the more that networks become softwareized, the more that people will think that they ought to be able to control them themselves. So you'll see a whole diversity of new classes of service provider and stakeholder, as well as the traditional national mobile operators. Some of those might be governments, they might be road and rail authorities, there might be mix of the virtual operators who have some of their own physical infrastructure, tower companies and others. This is going to be quite interesting, and that's actually quite an opportunity for companies in the IXP space, in my view. So I'm going to leave it at that, and I'll say that there's a lot of hype, and there's some really interesting reality around 5G. It's going to take a while. There's going to be multiple generations of it, but despite the hype, I would say it is just another G. In the same way that a Jaguar is a fast car, but it's just another car. And I will leave it at that, and hopefully there's some questions and answers. Michael, over to you.
Thanks, Dean. I think we open up to the audience for any live questions. Do we have any live questions? I guess silence means we don't have any questions.
Okay. Oh, well, either everyone's stuck in the other room, or I've scared them, one or the other. But if people want to reach me, I'm Disruptive Dean on Twitter, or add me on LinkedIn, and I usually have plenty to say about most things, either publicly or privately.
Okay. Thank you, Dean.
Okay. Thank you. Cheers.
Cheers. Okay, we are back. So I'm going to continue this 5G session. So I'll be kind of continue where Dean actually kind of talked on this from an other point of view. I'm going to touch on 5G more from a transport network requirements and architecture to actually provide transport for 5G traffic. So I think Dean kind of touched on obviously, some of the figures where we basically see that by 2025, we are going to have 2.6 billion 5G subscribers connected. This obviously puts some demand in regards to the next generation transport networks. So I'm basically going to spend, the next 15 minutes trying to at least give you a high level overview of the challenges to transport 5G traffic. And Dean kind of alluded to some of the 5G kind of applications or services. So there shouldn't be anything new in that sense, but obviously we have the mission critical services. We have things like autonomous cars, and then you go into the massive IoT, which Dean touched on as well, where you basically provide connectivity for a new wave of device types. And then you go into both the fixed and the mobile broadband. And as we heard in the previous presentation, obviously you have things like increase in bandwidth to 10 times bandwidth per connection, low milliseconds latency, 5 nines reliability, and 100% coverage, so on and so forth. So I think this kind of sets the ground for how and in what manner you should actually transport this traffic. So to kind of take a step back here and for all of us to understand where the challenge is here. Now, if you look at the current 4G kind of architecture, so what you'll have is a couple of big data centers where you basically then obviously have all your applications running for your mobile network. Now, with 5G, this is going to completely change. You're actually going to go into thousands of small micro data centers, which basically means that the architecture is going to change. And this is due to the fact that if you look at one application, just to pick one, which is many times talked of, which is basically the autonomous cars. So if you look at the current 4G, the with a few cloud data centers, now you have a scenario where you have a car driving. If you would actually have this deployed in a 4G network, you would actually look at more than 80 milliseconds latency to basically get a response back, which would mean that the car would move over 4 feet during that period of time. Now, if you compare that to the 5G, where you would have these thousands and thousands of small micro data centers, the same scenario would actually mean that you have less than 5 milliseconds latency, which translates into the car would move less than 4 inches by that time. Hence, this is kind of one of the fundamental things, obviously, with 5G. Now, to basically add to that, the NFVI architecture, how you actually build up this. Today, obviously, you have, everything is virtualized. You have VMs running your applications. And, going forward within 5G, you would have containers doing the same thing. And that basically means that all of the applications, so be it the 5G core, the EPC, the IMS, the virtual RANs, as said, 5G is cloud native, which basically means that all of these application services are going to run virtualized. So you can imagine that you still need to have a transport network in place here. So taking this a step further, now as the network architecture has transitioned to cloud-based connectivity and obviously software-defined networking control for those ones, I'm just picking one example, being the 5G RAN, which is a virtual service, as I mentioned in the previous slide. So service providers are able to actually dynamically support a range of use cases with varying demands using SDN control and orchestration. Moreover, with the advantage of running virtual network functions, as I kind of showed in the previous picture, any open hardware like the various data centers that I kind of mentioned being a fabric is truly needed here. So with that said, let's actually move on to the next slide. This kind of shows you the 5G service enablers. We touched on a few of these. Obviously, you have the millimeter wave, you have the new channel coding, you have the 6 gigahertz massive MIMO, you have massive connectivity with the IoT things. But a couple of things I kind of want to point out here is the low latency networks, which I kind of previously showed in my example being, the autonomous cars, which basically have a demand on how you transport that network, that traffic. And then another aspect is obviously network slicing. So if we actually look at the network slicing part here, what it basically means is that you need to handle the tsunami of device-to-device communication that is expected with 5G. So the next generation networks will require, denser RAN architectures, amongst others, with distributed intelligence. And this is increasing the densification, which means more advanced topologies in the access part of the transport network, such as mesh or ring architectures, as well as an evolved front haul and back haul interfaces. So in addition to connecting physical radio sites, the 5G mobile networks need to support virtual network functions, as we saw on the previous slide, in order to enable network slicing and connect subscribers to the cloud-based applications, which basically means that you need to actually ensure smooth evolution into integrated 4G, 5G network requirements with scalability and things like that. So at the end of the day, this actually means that you have a network in place where you have multiple different applications, where you basically need to provide a network slice for a given application to be able to provide specific service level agreements or specific delays, latencies, things like that. So to basically look into this from the 4G to 5G network evolution challenges, what you basically have here is a 4G central RAN model compared to the 5G RAN model. What you'll have in place here is obviously on the 4G side, you had a backhaul, you had a front haul, while when you go into the 5G part, you can see you have your backhaul, your mid haul, and your front haul with different requirements. And as you can see on 5G, you start to talk about some kind of synchronization in place where you actually have PTP, so 1588v2, as well as sync-E being requirements. The sync-E part is obviously more like backwards compatibility with current metro networks, things like that. But as we can understand, this is truly putting new challenges on how you would transport the 5G traffic. So to kind of try to explain this shortly in a single slide, this shows you the 5G transport platforms and technologies today, what you actually have here. So you basically have three key building blocks in this architecture, which is the centralized unit, which is the CU. You have a distributed unit, the DU, and the radio unit being the RU. So together, these three main functions, these three main functional modules makes up the 5G base station, while the functions of the CU and DU were combined with the 4G baseband unit, so something called the BBU. Now, 3GPP, which is the 5G specification, introduces a functional split between the previous BBU design as a way to lower the transport cost and offsetting basically the significant increase expanded with the 5G transport rates. Now, the dual split RAN architecture is similar to the 4G BBU, where the DU resources are centralized in a pool for connectivity to RUs at multiple cell sites. So in this configuration, front haul provides connectivity from the DU to the RU. And since the DU are centralized, the resources can be pooled across multiple cell sites over the front haul spans. So this pooling capability enables the service providers to engineer performance demand for the RAN based on the region within the group of the cell sites, instead of based on individual cell sites. Now, individual cell sites performance engineering is very inefficient, since the dedicated DU cannot be dynamically scaled when greater performance is needed. Hence, you actually start to look at the cell site RAN architecture that offers dual functionality, providing low latency and centralized operation. Now you'll have the DU, RU, and the local CU users and control plane function, as well as the possible multi-access edge computing, the MEC functions. So you guys probably heard about the edge computing with the mobile edge. And all of these functions are co-located at cell sites to support latency sensitive applications. And you basically have a second CU user plane at the edge site for centralization benefits. Now, to achieve dual functionality, you basically need to have a DU resource and sliced over fixed allocation to resources for each of the two CU user planes. So this is pretty complicated in that sense that you truly kind of need to look into multiple different parts within the network. As I said, you had different requirements for the backhaul, for the mid haul, for the front haul. and how you have these different, the core network, the CU, the DU, and the RU. So as said, this is truly a short kind of high level overview of many of the technical challenges you have. But basically where I want to kind of stop this one is to show you the three GPP, so the 5G blueprint of basically, how it builds up. And as you can see, the transport network is a key function within the 5G networks. Even if you have a separate data plane, multiple control planes, things like that. So with that said, this was a true high fly in 10 or so minutes on truly some of the requirements for 5G transport networks. So to summarize, there's obviously a lot of things that need to be considered to transport 5G traffic. So I'm basically going to stop here. Any questions? If not, then I do believe that we have a break scheduled as the following thing. So the break, I believe, is 10 minutes or so. So thank you for listening to my presentation, and we go over to the break.